Well, it's great to see you today. I hope that you got all of your work done as you worked with that latitude and longitude last time and worked on your section review as well. Now let's get organized for our lesson today. For materials, if you would have on hand activity 1-4 on our agenda today, we are going to start with a review, of course, and then we're talking about map projections. We'll be doing some globe demonstrations with projections as well. And our main idea for this lesson today is that any attempt to project the globe onto a flat map or a flat surface creates problems of distortion. And then our goals for today: explain map distortion, why it exists, and how to reduce it, and also identify the types of map projections. Let's go ahead and start class today with our chapter verse, Isaiah 45:18. Go ahead and read this verse with me. For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it, he created it not in vain. He formed it to be inhabited. I am the Lord, and there is none else. We'll be starting with our review, and for this you need to match each word or phrase to latitude or longitude. So let's see how well you got those concepts learned. Okay, does meridians go with latitude or longitude? Longitude. Equator. Latitude. Parallels. Latitude. Which lines run north to south? Longitude. Great circles. Longitude. Remember, each longitude is also a great circle cutting the earth in half. 0 degrees to 180 degrees. That's longitude. Remember, half of a circle. Poles. Longitude. Remember that longitudinal lines go through, they intersect at the north and south poles. Labeled north or south. That is latitude. Greenwich, England. Longitude. The prime meridian runs through Greenwich, England. Prime meridian. Gave that one away, didn't I? Longitude. All the other longitudinal lines are measured from the prime meridian. 69 miles apart. Latitude. Intersecting. Longitude. Quarter circle. Latitude. Remember, that's how the degrees are measured from the equator, and it shows it can't be larger than 90 degrees. Which lines run east to west? Latitude. Small circles. Okay, latitude. All the lines of latitude except for the equator are small circles. Labeled east or west. Longitude. Time zones. Longitude. 0 degrees to 90 degrees. That's going to be our latitude. Half circle. Longitude. And degrees. Okay, both latitude and longitude are measured in degrees. Okay, I hope that you did well on your activity, which actually should have helped you use latitude and longitude to locate certain areas and to describe where certain places were. And be sure that you ask someone about that if you had any questions or any misunderstanding there. Now, today's topic is about map projections, and the big problem with flat maps is distortion. And distortion occurs in 1 to 4 areas. These are the 4 areas where distortion normally occurs: area, distance, direction, and shape. And you can see that spells ADS, or if you like better, you can say SAD with 2 Ds, or DADS. But that will help you remember area or size, distance, direction, and shape. Those are the things that are distorted when we try to show the Earth on a flat map. The problem is the Earth is a sphere, and there's no way to show that on a flat piece of paper without having some distortion. Now, on a globe, I don't think that you'll be able to see it from here, but if you have a globe, you can usually see that there are strips that are glued together. It probably doesn't show here, but if you have one at home and you examine it, there's a strip kind of like a football shape, and it gets narrow at the bottom, and those are glued together to make the globe, and these are called gores. And if we took those off of the map and laid them out flat, that would give us a gore map. And here's an example of what that type of map looks like. And you can see that if we curved those all around, glued these points, these tips down at one point, and glued these down at one point, we would have our globe. And you can see also that the areas are actually accurate. The east and west directions would be accurate because we have our straight lines, our latitudinal lines there. However, the north and south directions are distorted. You can see here that it curves. So all of those north and south directions are going to be distorted because of that. Now, the distance are accurate, but can you imagine how difficult it would be to measure? For measuring from here to here, you'd have to measure from here to here, then from here to there and add, and then from here to here and add. So measuring distances is very difficult, and it's obvious to see the final distortion. The shapes are very distorted with this type of map. So people have worked on solutions to the problem of distortion with map projections, and they actually project the globe onto a flat surface, and there are over 200 specific types of map projections, and be thankful that we're not learning them all. We'll actually just look at the main 3 types of projection today, and you should know as well that some maps don't really fall clearly into any of these 3 categories. Our main types of projections are cylindrical, planar or azimuthal, and conic. Now, each type of projection is useful for certain purposes because of its lack of distortion in a specific area. Okay, so certain projections distort in maybe the area and distance, while others might distort the shape. So it depends on what you want to use the map for. So we'll start with the cylindrical projections, and these are Mercator's, Good's, and Robinson's. And by cylindrical projection, we just take a piece of paper. I have a wire globe here. It's not an exact model, so it's just a rough model just to give you an idea of what happens with these projections. And then a piece of paper would be wrapped around it, touching the equator all the way around. And then we can just dim the lights and turn a flashlight on so you can see the projection. Okay, this is our cylindrical projection. You can see that the lines of latitude are straight. The longitude do look a little curved here on this projection, but as I said, this isn't, this is just to give you a rough idea of what the cylindrical projection looks like, okay? And Mercator's was the first important cylindrical projection. And on his projection, the lines of latitude and longitude are straight. Okay. Also, the directions remain constant. And that's a very important feature to remember about that, so you might want to star that in your notes. It's a conformal projection, which means the shapes are accurate. They are stretched, but they're stretched proportionally, so the actual shape is accurate, even though the area is distorted. So some of the continents look larger than they really are, or the islands look larger than they really are, because that is distorted, and also the distance is distorted. And the distortions increase away from the further you get from the equator, the more the distortions increase. And that's because on the cylindrical, when we wrap our piece of paper around, it touches the equator all the way around. So that's very accurate there. And then the further away we get from the equator, the more distortion there is. And I have an example here of Mercator's map, just to point out some of those same features for you on the flat map. You'll notice that the lines of longitude and latitude are straight on this map. Okay, and also let me point out the distortion that we talked about just a minute ago. Look at Greenland. See how large it is compared to South America? It's because we're getting further from the equator. This is where the area of distortion is greatest. Greenland is actually only 1/8 of the size of South America. So you can see the distortion is greatest along the poles when we get very far away from the equator. Okay, then there are other versions of cylindrical projections. One of those is Good's projection. And this is actually an interrupted projection. And we'll see in a moment what that looks like. It does have equal area. That means the areas are accurate. And the shapes are more accurate than the Gore, which is another type of interrupted projection. Or, well, the Gore is an interrupted map. It's not actually a projection. And the Good's projection does have distorted distance and north-south directions. And let's look at an example of Good's. You can see how it is interrupted. That means that there are sections where they've kind of cut away. Here's the Gore's. Remember that? The Gore's projection. And Good's is not that extreme. So it's not as distorted as Gore's. But it does have some advantages in that the areas are accurate. Okay, Greenland, see, you can see the Greenland's very small compared to South America. It's not way bigger. And also the shapes are more accurate than Gore, because most of the cuts that are made here are in the oceans. Only Antarctica here is really interrupted very much. It's mostly just the oceans. Okay? You also want to notice on Good's that the lines of latitude remain straight, but the lines of longitude are curved. See how they're curved? And so that is going to cause some distortion in the north and south directions, because notice here, zoop, it's curving over to the right and to the left. So the directions are going to be distorted somewhat. Also distances, we try to measure from America to Europe, the distances are going to be somewhat distorted as well. Okay, another cylindrical projection that's very popular is Robinson's projection. And in this projection, everything is distorted. The area, the distance, the direction, and the shape. However, all distortions are minimal. So it is a favorite projection. And it actually minimizes, even though everything is distorted, it minimizes all of the distortions. So it's a little more accurate. Here is an example of Robinson's projection. Notice that the prime meridian is straight. All of the other longitudinal lines do curve. Our latitude lines, however, remain straight across. Okay, so that's something to keep in mind, because you are going to be asked to recognize. That's why I'm trying to point out the look of the latitude and longitudinal lines on each of these projections, because you are going to be asked to recognize the different projections. Okay, most of the world map projections in your textbook are based on this Robinson's map right here, so you'll be seeing that quite a bit. Now think about this. What advantage does each projection, Mercator's and Goods, have over the Robinson projection? Okay, Mercator's has the directions that are accurate, whereas Goods has an advantage at the poles, the areas at the poles. Okay, now we also have a second category that we'll look at, and that is our planar or azimuthal projection. And on our globe, for the azimuthal projection, hopefully I'll show you two, that is where our piece of paper, this is our plane, so it's just straight, it doesn't curve around at all. And the globe, I'll show you from the side first, is going to touch, just one point of the globe is going to touch the piece of paper. Okay? It doesn't matter how we turn it, but just one point is going to touch the paper. So let's dim our lights and turn the flashlight on so you can see the azimuthal projection. Okay, here's our azimuthal projection, or a planar projection, where only one point on the globe is touching. You can't actually see the outline of the globe here, but we'll tilt the globe so that you can see the pole there, and there you can see the circular outline, and that's one thing that'll tip you off to the azimuthal projections when you see those. Okay, and I don't have a sample here on my map exercise, but in your textbook we have samples of all of these. But let's go ahead and look on page 11. If you turn with me, I'm going to look at the azimuthal projection, and here shows you what we did. One point on the globe is touching the plane or the piece of paper, and then here's what a typical projection looks like. Notice how the lines of longitude are curved inward. And then also, here's our equator, that's straight because that's the point that was touching on this particular azimuthal map. And then our lines of latitude that are above the equator are curving this direction. And then our lines of latitude below the equator are curving the opposite direction. So that's how you'll be able to recognize the azimuthal projection. Okay? And the azimuthal projection is, remember that each projection has its advantage. It's best for smaller scale maps and compact areas, so you won't see like your entire world maps in the textbook in the azimuthal map. It's most accurate in the center. That's where the globe touches the plane. Okay, so that's where it's going to be most accurate. And then where's the distortion going to increase? If it's most accurate in the center, then the distortion increases near the edges. And it's the same thing with the Mercator. Remember, the Mercator was conical. It touches all the way around the equator. That's where it's most accurate. As it moves away from the equator, it's distorted. For the azimuthal, it touches at one point. That's where it's most accurate, and as you move away from that center point, the distortions increase. Then we do have one other main type of projection, when we have our cylindrical, our azimuthal, or planar, and we have a conic, and that's where we just make a little cone over the earth, okay, like that, whoops, and make our projection that way. The cone touches one parallel all the way around. It can be the equator, or it can be above that or below that, but it touches the same parallel all the way around. So we'll just dim the lights and turn the flashlight on so you can see this conic projection. Okay, here you see your conic projection. Notice how the lines of latitude are curved, and the paper touches all the way around. Now it looks a little different once we unfold the paper. It's not going to look exactly like that, but that will help you distinguish the conic projection whenever we look at it. And we are going to go ahead and take a look at that projection in your textbook on page 11. You can see here, there's the cone all the way around, touching at one parallel, and it happens to be the 30 degree north parallel, and you can see they've highlighted that parallel. Okay, where is this map going to be most accurate? On this parallel, isn't it? Wherever it touches the globe. So the 30 degree north is going to be the most accurate, and then as we move away from that parallel, our distortions will increase. Notice that our lines of longitude here are straight. Once we unroll the paper, those are straight, and the lines of latitude are slightly curved. That is our conical projection. Now, the conic projection is best for wide regions, like the United States or the Soviet Union. As I said, it's most accurate along one parallel, and again, the distortions increase as we move away from that particular parallel. Okay. Now, you'll also notice on the map in your textbook that if we extended these lines, they would eventually intersect. If we had a ruler and drew all these, they would intersect in a point that would be the top of the cone. So that's another way that they're kind of slanting in toward each other, that you can distinguish the conic projection from the other projections. Okay, so those are 3 different types of projections. I want to give you just some general facts and tips, information about projections. The distortion on projections of small areas is generally minimal, so map makers don't worry about it too much. It doesn't really matter the type of projection. Often it's the azimuthal and the conical that are used on those, but it is very important to select the best projection for world maps or large regions. It's impossible to make a world map that is equidistant or accurate in distances. So that's why you need to decide what is the purpose of this map, which map would be best to use. Also, you might notice in your textbook that there is not a scale with many of these maps. And most of the time, if you don't see a scale, that's going to mean the scale doesn't apply because it's a world map where our scale won't apply because we can't make an equidistant or an accurate distance map of the world, or because that particular type of map distorts distance anyway, so a scale would be irrelevant. Another thing that you'll be seeing, I don't know, I don't recall having seen one in this textbook, but I'm sure there probably is an example somewhere, is the compass rose. You should have learned about that in earlier grades, and that shows the map's directional orientation. What orientation are we used to? What do we normally see at the top of our maps? North, right? And what's usually in the center of the map? Well, typically we have the United States at the center. But in Bible days, east was oriented at the top of the map. That's unusual, isn't it? So we would be looking at a map and it would be oriented this direction. Now, of course, that doesn't change the distances or anything else. It's just the orientation that's different. And even during the Middle Ages, many maps were oriented with the east or the Holy Land on top. What if we put the south at the top of the map? That would make things a little different too, wouldn't it? Okay. Then we would have our east on the left instead of the right and our west on the right. Most American-made maps, however, often place the United States at the center, cutting Asia in half, and that's what you see on this map here. Even when maps break the Pacific Ocean, they make Europe appear in the center. See where Europe is there? And it looks like it's close to the United States, but Japan appears farthest away. It's way over there on the east. It might not even show on your screen. However, on a Japanese map, this is an orientation we're not particularly used to, isn't it? Japan is at the center. You can see it right there in the middle of your screen. What continents get cut on this type of map? You can see South America is cut. I'm not sure, this isn't an actual Japanese version. I don't know if they have to cut the United States at all on their maps. if they have to do that or not. And you can see Greenland, although it's not a continent, it gets cut. What countries appear to be far away from Japan on this map? What appears to be close? So it does make a little difference, doesn't it? How the map is oriented to what you think is close to you or not. And people tend to feel more comfortable with things that are near, and they tend to care more about them. Like if something's happening in your city or your home or your state, you tend to know more and care more about that than something happening all the way across the world, unless you have some kind of connection there, missionary friends that live there, or family that lives there, or a friend that you have met there. How do you think people on each continent view the United States? Do they think of us as near them or as far away from them? Are they concerned about what's going on here or not as concerned? That's something to think about as we study geography this year, our relationship to these other nations around us. Okay, at this time I'm going to go ahead and go over your assignment with you. Today you want to read pages 7 through 11. That's what we just dealt with. The section review is on page 12 though, so you have to flip the page over. Don't forget to do that. And then I am going to go ahead and assign an activity. Activity 1-4. Let me take just a moment to look at this activity with you and show you what you're going to be doing with it. Activity 1-4. We're working with map projections. So that's the first thing. This is a comparison. It's two map projections overlaid on each other so that you can compare them. And it just leads you through some questions here, the borders, making some mark on the places that are the southernmost, easternmost, and so on. Then this is the part that I was trying to prepare you for during the lesson. This first section here excuse me, says, the textbook includes samples of all the projections discussed in your textbook. What projection is found on the following pages? So you'll look at page 45 and you need to determine what type of projection is used for that particular map. So keep in mind the different lines that we talked about during the lesson. Then you'll be finding examples. Find an example of each of the projections in the chapters below. Give the page number and the subject of the map. For example, Mercator's map, turn to chapter 13, flip through the chapter until you see a Mercator projection map, and then you want to write down the page number and the type of map it is. Let's go ahead and do the first one together. Turn to page 45, and here is the map that we find there. Notice that our lines of latitude are straight. They don't actually show the longitude, but what type of map does it look like it is based on Greenland compared to South America? It's the Mercator, isn't it? Because we can see this distortion that takes place there. Okay, so that's what you're going to be doing. You're going to be flipping through, identifying the types of maps, and looking for the different types of maps. Now, as you read your assignment today, don't forget to use your brain. Brainstorm. Here's the question I posed to you today. Which type of map projection do you think is best, and why do you think that that is the best type of projection? And then we'll go ahead and close with a where in the world question. Last time we didn't have time for one, but today our new question is, where do tornadoes usually spin clockwise?